here's another example of how to find the inverse of a 3 by 3 matrix. So I always start off with appending the identity matrix onto the matrix that I want to find my inverse of. I'm going to go ahead and cheat a little bit and turn it into a 3 by 6 matrix this way. Okay, so I'm going to go ahead and draw my line along the diagonal. I'm going to think about how I'm going to use that 2 to eliminate the -1 and the 1 below it. So the first thing I'm going to do is I'm going to multiply row 2 by 2, and I'm going to add it to row 1. And when I work on row 3, I'm going to multiply row 3 by a -2 and add that to row 1. So I have my instructions set out. Okay, so when I do the first operation, I'm going to take row 2 and multiply it by 2, so I get a -2 plus 2 is 0. -6 plus -4 is -10. 2 and 8 is 10. 0 and 1 is 1. 2 and 0 is 2. 0 and 0 is 0. When I do row 3, I get a -2 and 2 is 0. I get a 4 and -4 is 0. I get a -8 and 8 is 0. I get a 0 and 1 is 1. The 0 and 0 is 0. A -2 and 0 is, whoops, -2 and 0 is not 0, it is a -2. Okay, so I want you to take a look at this matrix. I have zeros in my bottom row. I just ran across a case that has zeros in my bottom row. If you can remember from our 2 by 2 inverse example, when we get a row of all zeros on the left-hand side, we know that this matrix is singular. Our original matrix, right up here, is a singular matrix, meaning it has no inverse or no inverse exists. So when you see a row of all zeros on the left-hand side of this dividing line, it means no inverse exists for this matrix.